Welcome to a session on helium neon laser. First of all, it is a gas laser. In gas lasers such as helium neon, the atoms are characterized by sharp energy levels as compared to those in solids which have broad absorption bands. Helium neon laser consists of long discharge tube filled with a mixture of helium and neon gases in the ratio 10:1. Here you can see this is a discharge tube. This long tube is called as a discharge tube, and it consists of two gases, mixtures of two gases, helium and neon, and the ratio of helium neon atoms is 10:1. Electrodes are connected to high voltage source to such as 10 kV. Here you can see from the diagram this anode and cathode, these are connected to high voltage source. Laser action is due to neon gas. Helium atoms helps to excite neon atoms. The discharge tube contains windows placed at Brewster angle. Here you can see the tilted windows are called as Brewster angle windows. The speciality of the Brewster angle windows is whenever the light passes through Brewster angle windows, it got polarized. That is the specialty of Brewster angle windows. Two mirrors are also present. One mirror is fully reflecting and the other is partially reflecting. Here you can see there are two mirrors, this one and this one. So this is called as a fully reflecting mirror and this is called as partially reflecting mirror. So if the light is intense enough, then partially it will allow outside. So this is the partially reflecting mirror system. Let us see the working of the helium neon laser. When power is switched on, electrons and ions produced in the discharge tube collides with the helium and neon atoms initially. So here when power is switched on, which is connected to anode and cathode, now electrons will produce as inside the discharge tube and they will make a collisions with helium atoms and neon atoms inside the gas tube. Helium being lighter than neon so that it gets excited more readily compared to neon. So initially helium atoms will respond quickly due to their lighterness when compared to neon atoms, so that they got excited to the respective energy levels. So they got excited to energy levels F2 and F3 of helium is so close to the energy levels of E4 and E6 of neon atom. Here you can see electrons collides with the ground state helium atom so that they may rise to either F2 energy level or F3 energy level. If you carefully observe the neon energy levels, E4 is very similar to F2 and E6 is very similar to F3. So, which means that F2 of the helium energy level and E4 of the neon energy level are parallel energy levels. F3 of the helium atom and E6 of the neon atom are parallel energy levels. When helium atom collides with the neon atom, they transfer their energy. This is known as resonant energy transfer. So, whenever the excited helium atom, either from F2 or from F3, if it make a collision with the ground state neon atom, they got the energy of the helium atom. Which one? Neon atoms got the energy from the helium atom. For example, if a helium atom from F3 is making a collision with the ground state neon atom, the ground state neon atom got the energy and it rise to the corresponding energy level E6 because F3 helium atom will gives the equal amount of energy to the neon atom to rise to the equivalent energy level E6. Similarly, if a helium atom in F2 if it is able to make a collision with the ground state neon atom, then it rises to E4 energy level. In this way, the population of the neon atoms in E6 and E4 continue to increase. If it continues, then what happens? Population inversion slowly takes place. So E6 is a metastable state. Transition from E6 to E3 produces the characteristic wavelength of 6328 angstroms. Here E6 is a metastable state. Metastable state means which have long lifetime, which means neon atoms which are excited into the E6 energy levels can spend a large amount of time when compared to the normal energy levels in this particular E6 energy level. So E6 is called as a metastable state. So it is easy to, if any energy level having that property, or if it is a metastable state, we can easily achieve the population inversion. Transitions from E6 to E3 produces the characteristic wavelength of 6328 angstroms. Here E6 to E3, this transition. So once E6 is populated more when compared to E3, population inversion takes place between E6 and E3. It causes stimulated emission of radiation. Due to that stimulated emission of radiation, laser light of 6328 angstroms produces between E6 and E3 energy levels. Other two wavelengths produced are 3.39 micrometer and 1.15 micrometer. They are eliminated. Here you can see population inversion not only will take place between E6 and E3, rather it also takes place between E6 and E5, E4 and E3 also. So the population inversion between E6 and E5 leads to a laser light of 3.39 micrometers. The population inversion condition between E4 and E3 leads to a laser light of 1.15 micrometers. So of course they are unwanted laser radiation. So what they will do is they will place some absorbent materials inside the gas discharge tube. So those absorbent materials will absorb these radiations. Which radiations? 3.39 micrometers and 1.15 micrometers. Only the output is 6328 angstroms. Brewster's window made of glass or quartz absorb, this is something 3.39 micrometers and 1.15 micrometer wavelength and allow 60 to 8 to pass through. Mirrors provide optical feedback. They are coated with multi-layer dielectric material which only reflects 63 to 8 angstroms. Here optical feedback will takes place between these two mirrors. This is the first mirror and this is the second mirror. So um, the laser radiation initially one photon will come out, one become two, two become four, four become eight. These eight come out from this Brewster angle window and hits this mirror, partially reflecting mirror. This partially reflecting mirror reflects back because its intensity is very very less. So once they pass through discharge tube, once they enter into the discharge tube, stimulated emission continues. 8 becomes 16, 16 becomes 32, 32 becomes 64. Once they leaves the discharge tube and they hits the fully reflecting mirror, so it is completely, these 32 photons got completely reflected by these fully reflecting mirror and they once again enter into the discharge tube. Once again stimulated emission takes place. 32 becomes 64. 64 becomes double. One, 128. 128 becomes 256, like that. So it becomes double by stimulated emission, and if the intensity is enough, high enough, then this beam is passed through this particular partial reflecting mirror. Then the output beam is laser beam. So these two acts as optical feedback or resonating cavity. That setup is. Let us see some applications of lasers. Ruby laser, measurement of distance using pulse echo technique. Drilling of high quality holes is the purpose of the Ruby laser. There are major some striking applications of Ruby laser. If you take helium neon laser, it is mainly used for metrological applications and barcoding reading. Carbon dioxide laser is mainly used for welding and cutting. Argon ion laser is mainly used for welding retinal detachment. Semiconductor laser is mainly used for laser printer. These are some applications of lasers. Thanks for watching.